Yeah, hello dear student. Today we are going to discuss about the frameworks which is used in machine learning, deep learning and large language model. So let's see this. So in deep learning framework, like you can consider like TensorFlow and PyTorch. Basically it is used to handle the high dimensional data and complex neural network architecture, like which is suited for NLP tasks like involving sequential and contextual information. Now what can be you can say about the sequential? So sequential in the sense like sequence to sequence one, like you can consider like RNN and LSTM. If you're considering contextual information, that means you are talking about the BRT and GPT-3 models, and they are like very good because they work on a parallel encoder and decoder concept, but this is a sequential encoder and decoder part. So what is the good benefit here by using the parallel one, that they are able to capture each and every word, and they are able to handle the vanishing gradient problem. Also they are like they understand the dependency of the sentence even for the long dependency as well, right? So again, like you can say these are the things that you accordingly use. Like you can say, like if you are considering the ML traditional unlike traditional ML framework, which we use feature engineering and solve models, like deep learning framework supports end-to-end learning from raw text using embedding. So like you can convert the text into the vector. You can consider like a attention mechanism, like a self-attention, right? And transformers, because they are able to handle the vanishing gradient. And this allow for a better handling of notions. You can say like a context, text, syntax, and semantics in natural language data. So you can say basically deep learning frameworks are very nice. What are the trade-off using a high level NLP framework like SPA-CY? Okay, it versus a lower level one like NLTK for text processing. If you are using SPA-CY, that is far better. Like you can say high level NLP framework like SPA-CY are designed for the ease of use and efficiency, providing pre-built components for common tasks such as tokenizations, name entity recognition, and dependency tracing, right? They are optimized for performance. They are optimized for performance and offer easy integration with deep learning model. In contrast, lower level framework like NLTK provide more granular control and flexibility, but may require more effort to configure and use. So NLTK offer a broader range of algorithm, linguistic resources which can be useful for research but might be less efficient for production systems. SPSCY designed for, like you can say SPSCY is more more efficient because it provides pre-built components for common tasks. Okay. Framework designed for LM such as, okay, how do the framework for large language model LM differ in their approaches to fine-tuning model compared to those for traditional ML tasks? Framework designed for LM such as Hugging Face transformers offer specialized tool and APIs, okay, for fine-tuning retail language model on a specific task. This framework handles large-scale data processing, okay, and model management, and often include methods for transfer learning and domain adoption. In constant, digital ML frameworks may focus on the training model from scratch or with simpler architecture, require more manual effort for hyper tuning and model adjustment. Okay, how to so basically LLM you can say like fine tuning models compared to, okay, so this is far better, like you can consider like this. Oh. So you can consider like the framework designed for LLM Framework designed for LLM such as Hugging Face Transformers offer fledged tool and API for fine-tuning pre-trained language model on the specific tasks. This framework handle large-scale data processing and model management and often include methods for transfer learning and domain adoption. In constraint, ML frameworks may focus on training models from scratch or with simpler architecture, require more manual effort for hyperparameter tuning without model adjustments. Okay, got it. In what ways do the modern NLP frameworks integrate pre-trained model and what are the implications for transfer learning? Okay, so model NLP framework, what you can say. Model NLP framework like Hugging Faces is transformers provide extensive library of pre-trained model that can be easily integrated into the new application. This framework facilitates transfer learning by allowing users to fine-tune pre-trained model on a specific task or data set. Okay. This integration simplifies the process of leveraging state-of-the-art model, reduce the training time, and improve the performance by utilizing knowledge learned from large diverse data set. Process of leveraging state-of-the-art model, reduce training time, and improve the performance by utilizing the knowledge learned from the large data set. Provide extensive library of pre-trained models easily integrated into the new application. Okay. Transfer learning by allowing users to fine-tune pre-trained models. Okay. Fine-tune pre-trained models specific task or data integration. Simplify the process of leveraging state-of-the-art models, reduce training time, improve performance, learn from the large diverse dataset. How to deep learning framework handle GPU acceleration and what impact does it have on training large scale NLP? Deep learning frameworks such as TensorFlow and PyTorch offer built-in support for GPU acceleration which speed up the training process. PyTorch offer built-in GPU acceleration, okay, which significantly speed up the training process by the parallelizing computation. GPU are particularly effective for handling the large scale matrix operation and backpropagation required for training deep learning network. This capability is crucial for large scale NLP model and it enables faster experiment and reduce training time from weeks to days or even hours. Okay, great. Such as TensorFlow and offer built-in support for GPU acceleration, okay, which training process by parallelizing the computation. GPUs are particularly effective for handling the operation and backpropagation required for training deep neural networks, okay. Large model system, okay. So how do you decide between the TensorFlow and PyTorch for building the deploying NLP model, considering factors like ease of use and performance? The choice between TensorFlow and PyTorch often depends on a specific project requirement and personal or team preference. TensorFlow is known for its production-ready features such as TensorFlow Serving for model deployment and TensorFlow extended TFX for end-to-end ML pipelines. Okay, Serving for model and TensorFlow extended TFX for end-to-end ML pipelines. PyTorch, on the other hand, is replaced by this dynamic computation graph and use case, which makes it particularly popular for research and rapid iteratory. Performance-wise, both frameworks offer competitive results, but the choice may hinge on the development environment, available tools, and deployment need. Okay. Production-ready features such as standard serving for model deployment, end-to-end ML pipelines. Okay. PyTorch, on the other hand, is based for its dynamic computation graph and the ease of use, okay, which makes it particularly popular. Okay, so what are the architecture considerations using a framework for developing a custom LLM from scratch? So when developing a custom LLM consideration, the choice of architecture, transformation-based model like BRT or GPT, the scale of the model, number of layers, attention head, and computational resources required. The framework support distributed training Okay, any present data handling. Additionally, attention to pre-processing pipeline, memory management, and optimizing strategy is crucial for training large models. Framework with robust support for this feature like PyTorch and TensorFlow are often preferred. Okay, how do frameworks support the development of multitask learning model in NLP? What are the challenges involved? The frameworks support multitask learning by allowing the sharing of model parameters across different tasks while optimizing the multiple objects. This can be achieved using shared layering neural network, a specific model designed for the multitasking learning. Challenges include balancing the different task objective, managing model complexity, and ensure that the model generalizes well across tasks without overfitting. Frameworks like Hugging Faces, Transformers, Transformer provide tools to facilitate multitask learning through pre-built architecture and training utilize. The framework support multitask learning by allowing the sharing of model parameters across different tasks while optimizing for multiple objectives. Objective. This can be achieved using shared layer in network as specific model for the multitask learning. Challenges include balancing the different task objective, managing model capacity, and ensuring the model generalization again. Discuss the pros and cons of using a modular framework versus an all-in-one framework for complex NLP pipeline. Modular framework SPACY NLTK offers flexibility by allowing users to choose and combine different components like NLTK, tokenization, drivers, BIOS. Okay. This can lead to the highly customized solution, but may require more integration effort. All-in-one framework like Hugging Face transformation with built-in function and tools by deployment, but potentially limits custom problem. The choice depends on the need for flexibility versus convenience requirement for NLP pipeline. Allowing you to choose and combine them and more integration effort. Okay, Hugging Face transform. Okay.